Hello, Coach.
Hello, everyone. Just give it a few more minutes.
Okay.
People are still joining, so
All right.
wait for them for 2 minutes.
Yes, sir.
How is everyone doing, by the way?
I'm doing good. How are you?
Oh,
I'm
good.
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 Having fun with FTC?
Oh, there you go. Here I am.
Uh-huh.
All right.
Where's the... Hmm.
Need to enable access to the camera.
Yeah, hello. Hey, Aiden.
Yes.
Now, how do I mute?
Hi.
Dude, how do I change my background? It looks so weird. It's like blurry and stuff.
Just
Okay.
when he starts presenting, I want you to mute your audio. Okay.
Okay.
All right, guys. So let's move on. So hello, everyone. I'm Sunil Napre. So I'm coach for Byte Bandits team, and I have about 23 years of experience in CAD. I worked in a lot of mega projects. And this is my passion, and that's why I would like to just take it further, give you guys some guidance, be helpful for you guys. So feel free to say anything, though I would expect everyone to keep their mouth mic mute so that we do not interfere others. But yeah, in case if you have any questions while uh, presenting, feel free to just raise your hand, and then yeah, you can either chat. Put your messages on the chat, or you can just say, okay. All right, so with that, let's move on. So the agenda for today is I would like you guys to get it started. uh, this webinar is basically for the guys who have just started on shape or CAD work, or may not have started. So I just want you guys to get a first step towards the CAD. uh, some of the experienced people, of course, they can get some guidance that how to get expert into it. But my main motto is to get you started. So with that, let's move on. One of the things a lot of people were asking me, give me 1 second, people are still joining, so let me just accept them. Okay. So one of the things a lot of people were wondering and a little bit doubtful to attend this is because they were thinking, oh, they need some kind of CAD experience to join this webinar. So no, not really. You do not need any CAD experience. That's what my job is, to get you started. So even if you have a zero experience, you don't know what CAD means, even don't worry about it. Just feel free uh, to ask any questions if you have any. As far as the requirement is concerned from the electronic side, all you need is your laptop with an internet connection. A decent laptop, of course, because these are CAD software, so they require little better graphic card, but a decent laptop should work. Uh, so you can use it on mobile or your iPad and all that, but as a student, just to get it working, laptop or MacBook should be good enough with mouse and all that. All right. So what we are going to cover today, 1 second, sorry, people are still joining. Okay. Welcome everyone who joined it. So yeah, what we are going to cover, we are just going to touch base the basics of engineering drawing because that's the base. Uh, And I would like to emphasize on that to learn the basics of engineering drawing, because most of the people, what happens is they just directly jump into the CAD without understanding the basics, the technicality, and all that. And what happens over the period of time is like they do it, but they do it in a long way. So something they could have done much better in pretty quick way. Um, it takes just more time or more time because they are not following the right approach from the beginning. Then the fun thing is, of course, we are going to touch Onshape. So we are going to a little bit of sketching part, make some part to some assembly, just to get a taste of it. And then, yeah, a little bit of 3D printing. So we are all set. Everyone is good. Just give me a thumbs up if you're all good. Okay, great. So one of the, okay. So I would like to set the expectation for you guys itself. So like I said at the beginning, don't worry about it if you don't know what CAD means, okay, what drawing means and all that now. That's why you are here, and that's what we are going through. So as a FTC or FLL, there are quite a few FLL participants as well. So as a team member, you can contribute at any level as long as you have little bit of knowledge. And that's the little bit of knowledge we are going to cover. But like you can see over here, you can do just a small thing at a beginner level. Just make some part. That's it. And you should be good with it. You don't have to wait until you get expert level and touch CAD. No, you don't have to, because you start from the beginner and you keep doing, and you reach to the expert level. It's one step at a time. So don't keep high expectations from yourself that, oh, I don't know this. So can I be part of the team? Can I contribute to my team? No, you can still do it based on it's just, you have to follow the right approach. Okay. So basics of engineering drawing, what it is. It is basically, of course, it's about the technicality, but the most important part, what I think at your level, is learning to think in 3D. What I mean is, we can see the 3D graphics and understand those things, but when we are developing something from scratch, which we have never seen it, so we have to visualize those things in our mind, like how it's going to look like, how it's going to work out, not the other way around, like, okay, let's make it and see how it's going to look like. Of course you can do that, but that's again a long way thing, that you make it and then you realize, oh no, this is not I wanted, right? Or this is not what I was expecting. A lot of times it happens with the teams, that they design it, but then they realize, no, this is not something came out in a way what we were expecting. So focus always on improvising your 3D visualization skills. And D is, of course, over here is the dimension. We'll talk about what dimension means in our case. So let's talk about drawing. So drawing is the most important part of uh, entire CAD process or design process, though it is the last part, I would say. Not really, but kind of last part as far as the CADing is concerned. But it is the most important part. Why it is? Because this is the way everyone communicates. We can make sketches and all those things. We can make a lot of drawing, um, paperwork. But unless it is in a way that people can really make something out of it, right? It's of no use. So drawing is the document that has all the technical information which is used at different stages of the production. Now, it could be anything, like if your house is being made, probably your parents may be working with the architect to make a drawing, right? When the builder is making the house, he'll be looking at the drawing and making according to the drawing. So at every stage, the drawing is the key thing which everyone follows, so that what was expected versus what is delivered is aligned. And it's again, it's not like everyone is following a different drawing methods. It's international language. So if you're following a certain standard, if you uh, give your drawing to anybody in any part of the world, as long as you're on the same page, they can fabricate the part what you're looking for. So that is very important. Okay. There are 2D versus drawings. So 2D drawing, what you can see in the right, this part of it is 2D, while this one has a 3 dimension. And we'll cover a little bit more about like how it is 3D while this one is 2D. But depends on what your need is. Like if you're for your FTC, right? If you're making one plate, let's say support plate you're making, so it's just a flat plate. So you don't need necessarily need a 3D drawing for it. The 2D should be good enough. But at the same time, if you wanna print a 3D part or you wanna explain the entire design to someone, so you need a 3D drawing for that. Okay. So I'm sure you, most of you guys, not yourself, but your team must be working on sketches, something like that. So while the sketches are the most important thing, because this is the first place where anything in your mind comes on the paper. Okay, we can have a lot of things in the mind, but unless it is on paper, it's difficult to explain people like what's going on, right? So making a concept sketch is very important because it is the first step. Okay, because if you start directly on the CAD or making the formal drawing, it's going to take uh, days for you. But before that, so you cannot wait and then at the end of the day you realize, oh no, this is not what we were talking about. So the making the hand sketch is the easiest way to get with it, explain to each other, talk to each other, and then go to the further detailing. But do you think just the sketch enough is good enough for us to fabricate the part to make the robot as we want it? Right? No, because
No,
it's just give you, yeah, go ahead, please.
no, because it's probably like not really accurate to what you might need in
Correct.
like for the actual CAD, like all the measurements and stuff.
Correct. Exactly. Absolutely. So yeah, so the sketch, right? It's something that came in your mind and you thought of it. Like but when we go into the CADing, making it more, making it more detailed, we realize, oh, yeah, we think a sketch is going to work out, but when we are going into the actual detail, it's not fitting with each other, right? So that's where the CAD comes into the picture. So of course we should, as a part of team, to make the expedite the 3D process, we should start with sketching, but then of course we have to jump into the CAD in order to get it done in real world. Okay. Sorry, I'm keep looking at my other monitor because people are still joining. So my apologies. All right, so let's look at in more detail technical way. So let me ask you, how many of you have heard about the word Cartesian coordinate system? None? Okay. Anyway, so you guys must have heard, must have worked on the 2D graph system, right? A lot of people must. Depends on your grade. I think 7th grade onwards, you guys work on the two-axis, two-dimensional graph system. So how the Cartesian coordinate system works is we have two perpendicular axes. The horizontal axis is called x-axis and the vertical axis is called y-axis, pointing positive towards up, negative towards down, same way positive towards right, negative towards left. Yeah. So this is the intersection of both axes, is called origin, which is of course called 0, 0. And then any point in the space, right? It is measured along the x-axis. So in this case, along the x-axis, we have 2 units, and along the y-axis, we have 3 units. So we always measure it's 2 in the bracket, 2 comma 3, which is x comma y. Always we follow the sequence of x comma y. We never do it in a way as 3 comma 2. And this is what we have to always pay attention to. Anyone has any question on this? No? Okay. All right. So, and this is again, like if you look at your GPS system, right? So in GPS system, the same way you'll find the latitude and longitude. So they are similar. It's just a different terminology based on the different systems, but they also have the same thing. Like your car, you can find out where it is located, though you just see the map. But if you go into the details, you will see there is latitude and longitude. Okay. Now, the 2D was just a 2D. It's a flat paper, right? But in reality, our objects are always three-dimensional. So that's where the third dimension comes into the picture, which is called Z. Again, the Z-axis is perpendicular to the XY axis, pointing plus upward and negative downwards. The same way, we mention any point in the 3D space, X, Y, and Z coordinate system. Okay, so in this case, the 3 unit is towards X, in parallel to X, 2 units in parallel to Y, and the 4 units in parallel to Z. So this is how we mention, okay, where is the object located. But do you think, is there anything missing with it? So
The other
if you can't
planes.
guess, just, sorry, go ahead.
The other planes.
Not really other planes. Of course, those are reference planes will come later on. We'll cover those later. But the thing is, like, if you've seen in your car, right, you might have seen the GPS many times, very often, right? So when your car is, let's say you are in a parking place or somewhere, when you are not really driving, your car is stationary, and you look at your car itself, or sometimes you will see your cars is in the GPS, the face of your car is not pointing towards the right direction, right? The reason that happens is because it's just checking into the 2 dimension. Um, it's not looking at the orientation of the car. Orientation of car is determined based on the motion that it knows that, okay, previously it was at particular location, now at this location. So which direction the car is moving, and according to that, it identifies the face of the car. Otherwise, if you're just sitting in the parking lot and you go to the GPS, very often it happens that it's pointing towards the wrong direction. So basically, the location, it shows you the location in 3 dimension, but it doesn't give the orientation. And that's where the orientation comes into the picture with each axis. So these are, with including the orientation, it makes the total 12 degrees of freedom. How it makes it is right and left, 2 linear movement, same way in all 3 axes. So that becomes a 6. And then along to each axis, like let's say if you're talking Y, it can rotate clockwise as well as it can rotate anti-clockwise, right? So 2 plus 2 is 2, the rotation, which is also called roll, pitch, and yaw. That makes a 6 degree of freedom, and then linear motion as a 6 degree of freedom. That makes it total 12 degree of freedom. So once we know the 12 degree of freedom, we can easily place our object in CAD. Like when we are placing it, we know, okay, what direction we need to rotate it. Okay. So for that, let's go to the next one. A quick exercise for you guys. Can you guys identify from which one is solid, surface, or flat? You guys can say, or you can put it into chat. Just one quick minute exercise. Let me see how many of us can identify details. Okay, I'll just move on. So give me 1 second. While you guys are thinking, let me just check chat. Yeah. All 3 look the same. Yes, they do. They do look the same. That's correct. All right. So what if I say that one of them is cube, another one is a 3D surface, another one is just a 2D hexagon? You will wonder how they all look the same, right? And it does. So I'll show you some magic here. Okay. Isn't it the thing? They all look the same. Now you'll see the magic. One of them is cube, another one is the surface, another one is just a 2D object. Let's give it a more realistic view. Okay. So now you'll see. Do you agree now that this is a cube? This object is a cube.
Yeah.
This is just 3 surfaces perpendicular to each other. Okay, and this is nothing but one flat hexagon, right? Isn't it good?
Yeah.
All right. So what it means basically that our eyes need more visual clues to identify the object. Just based on one picture, we may not be always able to identify what it is, right? So we need more clues. How do we get more clues? So let's look at in the next slide. So let's talk about different views. Have you guys heard about the orthographic views? May not be, of course. So orthographic views are the 2D views, which is in the 2D plane, like we make sketch in 2D. Then we have isometric view. So orthographic view, if you look at it, has height, has width. Okay, so just 2 dimension. While if I look at isometric view, it has length, width, and height. So there are 3 dimensions given. So it gives us, the isometric gives us 3D visual uh, effect, while the orthographic is only 2 dimensional. There is one more, which is perspective view, which is also similar to isometric, but you'll see this is converging, right? So this gives a more pictorial views. Now, when it comes to the engineering drawing, the orthographic and isometric views are the most common views. Okay, of course, there are more than these views, but we are talking about at the moment just the common ones, right? So the orthographic and isometric views are the most common views. The perspective is mostly used in the architectural drawing to give your house a real pictorial view before it is actually made. Now, how do we generate it? So let's assume this is a cuboid. There is an object placed inside. When you're looking at from the top, it's called the top view. When you're looking at from the front, it is called the front view. And when you're looking from the side, it is called side view. In this case, we are looking from the right side, so it is right side view. Other side will be the left side view and the back and the bottom. Okay, so these are again 2 dimensional views generated directly from the parallel to the plane. Okay, so for creating any drawing, you need at least 2 views to get the full picture of it, if not more. Okay, sometimes 3 views or 4 views are required. So how do we generate it? So again, you'll see those 3 planes. You have the X plane, you have Y plane, and you have Z plane. So what we do is whenever we have the object, we draw the line parallel to those planes and whatever see. So if I'm looking at this direction, this is the shape I see. That's what I'm drawing. Same way when I'm looking at from this side, this is the rectangle, which is this, and the small rectangle, large rectangle, this, and the plan view is here, right? So those are the views over here. And what we do is, because again, this is in the 3 dimensional kind of, because they are perpendicular to each other. To understand it, what we do is we open it. So it's like a box. You're opening the box sides. So you flip this one left side, you flip this one down side, and that's how the top view comes at the bottom, the front in the middle, and the right view is on the left side. Pay attention to this arrow though. So whenever there is an arrow is given, that means this is your front view. If arrow is over here, that means you'll consider this is front view, top view, and the left side view. But in this case, this is front view. So this is right side view and then the top view. And this is called first angle system. There's more than this, but let's just be with it for now. Okay. Any questions anyone has up to this point so far? No? All good? Okay, great. Could you guys identify what kind of views are this? I'll just give you the clues that some of them are isometric, some of them are orthographic, but in orthographic also we have like many views, front, left, right, and all those. So either type in the chat and just say 1, 2, 3, 4, 5, what views you think it is.
5 is bottom.
Which one? 5 is bottom. Okay, good.
One's isometric.
1 is isometric. Okay,
3 is left side view, I think.
that's correct.
Is 4 top view.
Sorry, which one? 4th?
Yeah.
No.
Oh, sorry.
Try a little bit. You guys are almost there. You identified 1 as isometric, 3 as left side view, 5 is top view. All right, let's move on. Okay, so 4 is basically the front view, because if you see the clues, right? What clues you see over here? You see this gear. This gear is on the left side. And of course, these wheels are like this. So this, because the wheels are on the left and right, that means it has to be either front view or the rear view. Now, the second clue is because the gear is on the left side. That means we are looking at from this side. If we would have looked at from the back, that means the gear would have been on the right side, right? And then also you'll see this gripper, right? Which is over here. So this is a front view. The second is also an isometric view. There are more than one isometric views could be. Um, like there's northeast or isometric view, northwest, southeast, southwest, and more than that. Okay, so there are multiple isometric views can happen within one object. All right, great. So let's move on to this. Now, how to create? Okay, so all these orthographic views and isometric views we talked about. Though there are software available for it, if you want, I can tell you, and you can register for it. Also available for students free, but you need to register. But for the students who doesn't want to register in software and just want to do the practice for orthographic and isometric view. So what you can do is I have also placed a link, or otherwise you can just do the Google search. You can download orthographic graph paper, which is nothing but just a straight horizontal and vertical line equally spaced, or you can download isometric graph paper, which has 3 lines. You'll see 1 line, 2 line, and 3 line equally spaced. Okay. This is after class, you can do that. And so if you were to draw a orthographic view, okay, or set of orthographic views, this is how you can draw. Like for example, let's say your width is 6. So 1, 2, 3, 4, 5, 6. So this is your width and so on, right? So you can take a measurement. You can also go with the interval, like each uh, each square is like either 1 unit, 2 unit, 5 unit, or 10 unit, depends on the size dimensions given into your sketch. But that's how you can draw orthographic views on the orthographic paper. Same way on isometric paper, this is how you can draw. So you can see that though it's just a paper, it's on 2D, but it gives you the 3D appearance, right? And this is how you draw. Again, if your width is, let's say 6 units, length is, let's say 8 units, and the height is, let's say 8 units. So this is how you will draw and make a cube, or same way, little bit more complex. So these are the some simple exercises what I have given here, and I'll give you the copies. You can just send me the email separately after the class. So I'll send you the copy of this presentation so that you can refer it and you can practice it. But these are the simplest one. You can at least get it going and practice all different views. Of course, we do much more complex than this. And these are the after class exercise. So basically you will use this ISO view to generate its orthographic views. Same way for this. And you will use these orthographic views to generate isometric view for this. Okay. So feel free to try after the class and let me know what you come up with. You can feel free to send me your work, like just take a picture and send it to me. I'll be glad to give you the feedback on that, if it is correct or not. Okay. So with that, the basics of engineering we have covered. Anyone has any questions so far? Is it a little bit going over the head? Are you guys with me? Was it for you guys? Okay, no worries. So let's go to the fun part, which is Onshape. Okay. Uh, so what is CAD? So CAD stands for Computer Aided Design. Okay. Uh, was the CAD always there? Not necessarily. In past, when there was no computers, there were no CAD softwares. So people used to do all these on a big drawing paper. Everyone was drawing by hand. Everything as you draw today on computer very accurately, everyone was doing uh, by hand, all measurements and everything. But since the computer came, then after that there is advancement into development into CAD software. So the CAD softwares came into the picture, and that's how we are doing. Now, Onshape is not the only CAD software. There are many more. Like there is a Tinkercad, Blender. These are like simple go to start ones. They are free. Onshape is the very balanced one in between all these things. Then there is more advanced like Fusion, SolidWorks. There is AutoCAD, which I was showing you just now, the 2D one, right? The black screen. That was AutoCAD. Then there is free CAD scanner, and there are many more, countless CAD softwares. Every CAD software has their pros and cons, depends on your usage. Some are suitable for particular purpose, not others. So yeah, there are many CAD softwares, but we'll just talk about Onshape now. Okay. Have you guys heard about Onshape before, by the way? Okay, so great.
Yeah.
All right, cool. So let's dive a little bit deeper into it. Okay. So why we are talking about Onshape only, not the other software? Okay. Because first thing, it's free for the students or educators. So all you need to do is just go online, register for it, and then you can start using it. If it is a professional use, of course, you have to buy a license, but not for the education and the student purpose. Okay. It's compared to other CAD softwares. It's easy to learn. So basically, for your level, right, for FTC, FLL, FRC levels, there may be some FRC people here. It is easy to learn. It's not that complicated, and it serves the purpose what you need. Have it for your design. Second thing, it's cloud-based. So a lot of CAD softwares, they are like desktop-based. Basically, you have to download the file, you have to install your desktop, and then only you can use it. The good part with Onshape is it's cloud-based. So basically, all you need is your login credentials, and you're good to go. So anywhere you're, even you're going on a long drive, right? And you want to have fun with, you have laptop with you, you have internet connection. Yeah, you can just log in and just get it going. It's so fun. Once you start playing around with it, making your own things, you will realize how fun it is to play with it. It's just the first step that it is difficult. And that's where I come into the picture. Another best part is like as a part of FTC team or FLL team or any FRC team, or even in the professional world, right? uh, Multiple people be working on the multiple part of the of the robot, right? Like in your case, like let's say you're talking about FTC, for example. Someone is working on it, someone is working on outtake, someone is working on shooter, someone is working on other part of the robot, right? Now, people cannot wait for each other to complete their task. Everyone has to work in parallel. So that's where this comes into the picture. Is it's very collaborative. You can have access to the same model, same workspace with different accounts. So five different people can access the same account, work on the same different part of the robot, and it's real-time update. So they can see what others are doing, and they can continue their work without interrupting others. So it's very handy. Okay, so it's perfect for you guys. Let's go. So let's get it started. So now it comes to you guys. How many of you have the Onshape account? If you do not have it, I would say that quickly, it takes hardly 5 to 7 minutes. Just go ahead and get your account started so that we can do the live exercise. So if you want, I can also copy this link. Also copy this link in the chat so that you can easily access. Okay, so link should be in the chat. So here's the step. Just go to the link, follow these steps, and sign up your account. I'll just give you 5 minutes to sign up so that we can move on. We have limited time, so we have to keep it going. And even if it takes more time for you guys, that's fine. You can continue signing it up, and then you can catch up where we are. If you have any question for the sign up, please feel free to ask me if you're not able to do something. give me a up when you're ready. Otherwise, I'll just wait for a few minutes. Now, just keep in mind that once you sign up, it's going to send an email to you to activate your account, and then you should be good to go. Are you guys good? Okay, so let's move on. So, so people who have already signed up, and you can continue signing up because sometimes it does take a little bit of time because you this is the first time you're doing it, right? So you may not have. Okay, let me see what's the. Yeah, so iPad you can use it, but it may not be that user friendly. It's good for like on the cell phone or um, on iPad and all that. It's good for viewing it. Like let's say if you're someone is uh, making updates in the design and they just want you to see that how it looks. So for that purpose, I would say iPhone and iPad, all those things, tablets are good. But when you have to do actually work, I wouldn't suggest to go with the iPad or phone. Okay, because yeah, you have to having the mouse and keyboard really helps you a lot. You can it's not like it's impossible to use it, but it's just not user friendly. It's gonna take time for you to grab each item to it on oh, using your touch screen. All right, so let's move on. So we when before we jump into the Onshape, let's just quick look like how it works. So it's quick interface. So you can see over here. So left click on your mouse will use to is used for selecting an object. The right click, just keep pressing your right click and move your mouse. You can rotate the object. Uh, you are going to press the your wheel, that is for panning, and the scrolling the wheel is for zooming. You also have preset views on the right side. If you look at it, is the view cube. So you can see their top view, front view, right view, and all those things. And you can also see X, Y, Z axis, which we just talked about it, right? So you can just press on those different areas of the cube and it goes to the preset views. There are some camera and render options, which we don't need to talk about it, but yeah, this is why it is there. I just wanted to give you an idea. Now, again, to navigate it, there are a lot of toolbars, which as a new user, you might get confused. So once you start CADing for the first time, you'll see this toolbar, okay, in the Part Studio, where you'll see the sketch, and then these are the four basically features which are most of the time you'll be using. So it's extrude, revolve, sweep, and loft. Okay, these are the four key things. But of course, as you go into more and more detailed design, you'll be using more and more different features. Now, when you click on the sketch toolbar opens, and that's where you'll see all the sketching features. Okay, you can make rectangle, line, circle, and so on. Same way, when you have multiple parts, you're joining them together in a workspace. You'll go to the assembly view, and that's where you'll see assembly toolbar again with the different features of joining it. And if you're creating a drawing, like we talked about earlier, you can uh, yeah, someone is saying okay that I have the mouse and keyboard for the iPad, so that's perfectly fine as long as you can use it. It's great. Just try yourself. If it works out, wonderful. Okay. Same way, yeah. So once we are creating the drawing, actual the production drawing, you'll see the different drawing toolbars. And these are the different tabs where you'll see assembly, parts, and the drawings and all other things. These are the folders. So this is the quick navigation when you see it, so you know what is for what purpose. Okay. Each icon has, like I mentioned, for a different purpose. And when you just hover the mouse over here, it will give you like what this command or this button is for. Okay. Otherwise, you can of course go to the help section. You can type particular word, like let's say if it says rectangle, you can type rectangle in the help section and it'll tell you that how to use that particular feature. Okay. It's pretty easy. Same way the keyboard shortcuts. So when you get little better in Onshape, the keyboard shortcuts help you in the very quick way to speed up your process. The reason, because like with this toolbars, every time you have to go to a feature uh, and then you have to click on it, while the keyboard, like for example, this is the extrude, right? So I have to go and I have to click extrude button and then I can use that feature. While if I just use, let's say, shift E button on my keypad, right? So I don't have to move my mouse. And that is the best practice to make yourself efficient, that have your control or right hand on your mouse while left hand on the keyboard. So you can use all shortcut keys and other things with your left and with the right hand, you can use your um, mouse control, okay? Or vice versa if somebody's lefty.
Could you send the like the hotkey chart to our email?
No, means I can send it to you for sure.
Thank you.
Yeah. So yeah, so these are the one. Other thing is we have, this is again Onshape specific. So every CAD software is different. They have different nomenclature. They have different way of doing it. So this is Onshape specific. So what we do, so this is the document. That is the first thing you create. What does it mean? Is this is the main project. So like let's say if you're making a robot, the document is the thing where your entire robot is going to be there. Now, of course, not all the parts within the document is going to be in one place. You will have parts. Within the parts, you will have sketches. So part is the smallest 3D object that you make it. And the sketch is the 2D drawing that you use to make the part. Then once you have parts, you can join multiple parts in assembly. And then when you have everything and you want to send it for the production, let's say you want to send it for the CNC cutting, let's say you want to 3D print it, right? You can create a drawing. For 3D printing, of course, you have to export the file, but for production purpose, like if you're sending it to some vendor for cutting a plate for your robot, you can send them the drawing. You can nowadays, of course, you can send the soft copy in terms of digital copy and all those things like step file, STL files, and all those. But otherwise, if you just want to send the drawing, you should be good to for production. Okay. Someone is asking for some help. I'm not sure what it is. Okay. Then same way, other thing is how the documents are organized. So we have document level, we have top assembly level, sub assembly, and the parts. So with multiple parts, you can make sub assemblies. With multiple sub assemblies, you can make top assembly. What it means is the robot has like outtake, intake. So the outtake intake could be your two separate sub assemblies, but within the outtake or intake, there will be multiple parts. So those are these multiple parts. You can also import the parts like from the public libraries, from your other parts of the robot. So that is the library also comes with pictures like where you don't need to make it, but if there is something already existing on you can import. The way the part design works. Sorry, I'm being a little fast, but this is just introduction because I want you guys to work on it. So one part can have a different solid object, solid surfaces. So the way it works is you keep making different sketches. You keep extruding it within one part. So you're making sketch, extruding it, making sketch, extruding it. And that's how you can make the part. All right. So let's go with it. Are you guys ready with your Onshape? If not, you can see this recording later on and then you can work on yourself. But for now, let's move on. So what we are going to do is very simple exercise. For a beginner, also it's very simple. All we are going to do is create two parts. One is the prism, this triangular prism, and one is this blue base, and then we are going to assemble it. Okay. So let's move on to it. I'm just gonna go to the Onshape. Let's see. I believe you guys can still see my screen, right? You guys see the Onshape on my screen, right? So what you do is, first of all, just click on this Onshape icon and click on create. So when you click on create, use the drop down arrow, click on create and click on document. When I click on document, this is what it comes, and you can create that document in different workspace. So I'm just creating at this time in owned by me. Okay. And you can give any name. So let's say I'm just class exercise. You can give any name, whatever you like, and just hit create. Are you guys with me? Okay, all right, sounds good. So let's move on. So what we are going to do is, now we just talked about this sketch, right? Which was this. I'm just going to go back. So this was the sketch toolbar. We talked about it, right? So let's go back, and what we are going to do is, first, the simplest one we are going to start is with the prism. Okay, so let's click on sketch. You see this one, and then what it asks for you is to select the plane. Okay, so what I'm going to do is select the front plane. Select this, and for the quick navigation, what you can do is, on the view cube, just click on the front view. There are shortcut keys to directly activate that plane, but I'm just using the cube so that you guys know. And I'm intentionally not using shortcut keys so that you can see what feature I'm using. Okay, so you just click on it and then start making your triangle. So what we do is, we are going to use the line command in this case. Let's start from here. I'm just going to click over here and just random. You don't have to be precise, just do it here and close the triangle. Now, as per the exercise, the base of this triangle is 30, okay, and the height of this one is 60 minus 25. So I'm just going to pull up here for you guys to quickly look at it. So this base is 30, and the height of this triangle is 60, the total height minus 25, that makes it 35. So height is 35. So what we are going to do is, we're going to use the dimension. So just make it 30. Okay, then use another dimension, make it 35. It may not be equal on both sides, so I'm just going to use from the center. To this one. Okay, oh, that's why it's not picking up. I can make it equal. So you guys have your triangle ready? Let me know once your triangle is ready. So once it is ready, what we are going to do is just click the green check mark. Okay. And then I'm just going to tilt it with my right click a little bit. So you see the flat triangle. And then I'm going to use the extrude command. Select my sketch. It shows this direction, which is fine, or I can change the direction like this and just use length of our, let's look at what is the length of our triangle, which is 40 in this case, 40, okay, not 60. I was typing 60. It's 40. Okay, so that's it. If I want, I can rename this triangle as a prism. So this file as prism, but I'm just leaving for now. And then just click it. This. So if you're able to make it this one, congratulations, you just made your first object in Onshape. Now what we are going to do is we are going to go to another part studio. So just go and create another part studio because this is one object. Now we are going second one and we are going to make the base. Okay. So again, just keep in mind the shape of it. So I'm going to go the same process. Select this front view and then draw the shape. So let's say I start from here. Oops, sorry, I made a mistake. Okay, same way we are going to just give the measurements. And there are a lot of shortcut ways, but I'm intentionally following the long way for you guys so that you can understand. So we have this is 10, 15, and 25. So that's what we are going to do is 10. Okay, and let's look at other measurements. So we have this one as a 40, and this was 50, and this is 10. So let's just do that. How much was that? Was 50. Okay, now we just need to make it equal. You can see the measurements are there, but they are still not equal, right? So again, I'm just going the long way intentionally. So this was 10. So that's the 5 halfway and the 25. So this should be your 20. And this is 20. This is automatically 20. Okay. Same way. This should be 50. Okay. So this is how your sketch is done. Just click OK. Again, tilt it and then go to the extrude. Click on this. If you want to change the direction, fine. Make it 60. So this is done. Okay. Click OK. So your part 1 is there. Your part 2 is there. Okay. Then we'll go to assembly. Now what we are going to do is insert those. So there are many places you can insert, but we are just going to current document. We are inserting the part 2, which is this. Okay. It's very easy. Then you can go insert your part 1. Okay. Just randomly you can insert anywhere. You don't have to be accurate. So both the objects are there. Now what we are going to do is we are going to align them together. Okay. So let's click this. Okay. So both the parts are here. Then we are going to use this pass and make this one mate. Use this one, click on this and click on this. So now you can see the edges are aligned. It is already centered because it's already automatically putting into the center. But if you look at our picture, right? So is it towards this edge? No, it's in the middle of it, right? So if this is 40, this is 60, that means this is 10, right? So we need to create an offset. How we do that is just click on the offset button. And what is this direction? This is X direction. So I'm going to type -10 and this. So in the X direction, I've used the -10 offset and there you go. You can just click this ISO view. You can look at front view. You can look at other views. Okay, and then play around with it. So congratulations, your assembly also done. Again, if you're not able to finish it, that's perfectly fine. You can do it after class. And if you need any help, feel free to reach out to me. Or how are everyone doing? Anybody needs any help? I see a lot of messages. Sorry, I was not able to catch up with the messages. Okay, so someone is saying don't have audio. Hmm. Okay. Sorry, guys. Few people were having some issues, technical issues. But yeah, I'll be sending this recording as well. You can just send me an email separately, so I can send you the link of this recording. I can send you the PPT, and you should be good. Okay. So let's move on because we have just few minutes left. So I believe we have covered pretty much everything. Another thing about 3D print. So we covered the sketching, creating part, assembly. So for 3D print, it's pretty simple. Is all you do is either you go to the assembly views or part studio. Okay, you can right click the object and then you can just click on export. Once you click on export, you should know what files your 3D printer supports. The different 3D printers have different supporting files. But STEP is pretty good file, which most of the 3D printers support. Otherwise, there are some STL, 3MF, and all ACIS, different formats. And if there is format that your 3D printer uses is not here, you can use intermediate converter, like you can export into the STEP file, uh, and then you can use intermediate converter to convert from STEP to the file format that is suitable for your 3D printer. Okay, so we are good with the exercise now. So my key tips for you guys to continue this work, right? So first thing, work on this orthographic isometric views because that will give you the good grip on all these X, Y, Z axis Cartesian coordinate system to visualize it. Because it is most important, like I said, to understand uh, the methods, the nomenclature, and the 3D visualization. Once you're good with it, it'll be just cup of tea for you guys to make it. Trust me, it's going to be very easy once you get hold onto it. It does look a little difficult in the first place because it's not, we have never touched it, but don't worry about it. Okay. Uh, then just go with uh, so what else you need to do? You need to learn more about the components. So more you know about how each component works. So for example, a motor takes most of the load. So it needs a stronger structure, right? A servo motor is just for the small support. So it may not need that stronger support. So you need to understand the different aspect of robotics design, like how the different part works, what kind of loads they can act on your robot. So that will you to design the parts correctly. Because sometimes what happens is we are just designing very thick material, which takes long 3D print and takes a lot of space. So we have to make always efficient design. And efficient design is not just designing on CAD, but engineering it very well as well, which you can learn by learning the different aspect of the robotics. Uh, and just start. That's it. Just start very simple with this, like I was showing you in the first diagram, right? You don't have to be expert to work with your team or get started. Just start with a very simple object, like you saw. We just did a very simple exercise. So I'm sure some of you might have had the confidence that now you can at least work on Onshape. And then slowly, as you get better, uh, just make it more difficult for yourself, right? Pick better and better examples to do it. If you need further help, uh, I do offer courses like the full-time course for the computer-aided design, robotics engineering, which gives you the full overview of detail, not overview, but the detailed information of different aspect of how they work, why they work, the way they work. Okay, so it helps you a lot. And then there is a course for onboard Java programming. These are like 1 hour classes weekly. So if you guys are interested in these courses, For sure, you can contact me directly later on, and we can talk about it, about the fee structure and all. These are the course details for the CAD, which is Introduction to Onshape, then sketching, bar 3D modeling, real life FTC problems, 3D printing. And if someone is really interested, they want to do Onshape certification, which can give them an edge within their team and even in their resume. I support for getting the Onshape certified as well. It's a very good thing. Okay. Again, this is high level, but there's a lot more into it.